Hi, my name is Chris Kopacz. This is my final project presentation titled Inflation Forecasting with Forecasted Inputs for the class CSCI 116 in the fall 2025 semester. This project looks at forecasting U.S. inflation measured using CPI by leveraging commodity price data as predictors. Commodities are frequently viewed as leading indicators of inflation because they respond quickly to supply and demand and other geopolitical or economic events that can introduce a shock to the system. Whereas other economic indicators such as unemployment or jobs data tend to be lagging indicators of inflation because they are produced around the same time as the inflation data. There are two primary data sets used in this analysis. First is CPI, which comes from the FRED database, specifically the CPI AU-CSL data is used. This measures consumer prices for urban consumers across all items for a number of different goods and services such as housing, clothing, food and beverages, education, and medical costs. And this data is produced by the Bureau of Labor Statistics. The commodity price data is obtained from a publicly available Kaggle dataset. It's available from a number of different sources. This one just contained a concise number of predictors that were relevant to this project. After filtering the data for availability and relevance, the final predictors include cotton, natural gas, coffee, sugar, aluminum, Brent crude oil price, corn, copper, and wheat. And the relevant sampling period was shortened down to January 1997 through March of 2023. After downloading the data, all of the variables were aligned on the same monthly date-time index. Each of them was tested for stationarity and differenced when necessary. And the final data set was split within 80% 20% split to produce a training set and a test set. The test set was used exclusively for predictions after the models were fitted. No test data was used to train any models. That was only the training data. The models were trained directly with the raw predictors, after which those trained models were then used with forecasted predictors to forecast the CPI data into the future. Using the observed predictors or the raw test data, I established a baseline for the trained models for forecasting CPI. These three models showed the lowest RMSE values when using the raw predictor data. However, they don't hold much forecasting power, because these would essentially be the observed values that occur alongside the production of the CPI data, which gets to the focus of the project itself, which is to use a two-stage forecast process, where instead of using raw observed predictor values in the forecasting of the CPI, the predictors themselves are forecasted into the future, and then those forecasted predictors are used to forecast CPI. The performance of the models using the forecasted predictors expectedly underperformed when compared to the models when they were evaluated using the direct test set. However, the RMSE values are so close that it appears that there should be significant predictive power using the forecasted explanatory variables. An analysis of the residuals show that all of the model architectures, the linear regression, the XGBoost, and the random forest, produced comparable residual results. The QQ norm plots showed high deviation from the ideal case. The residual distributions were weak normally distributed, with a very heavy right skew and a few notable outliers to the left of the mean. More interesting, though, are the residual versus time plots. Up to about 25 to 27 months into the test set, the residuals actually appear to hover around a mean of 0, with fairly standard or constant variance. At 25 to 27 months into the test set, however, there appears to be a substantial shock or even a regime change. Some sort of economic factor that isn't accounted for in the data takes place. All of the residual plots show a sharp downturn, a sharp spike downwards, and then a steady increase up in the upwards direction. It's important to note that this same behavior is observed not only in the models that used forecasted predictors, but also the models that implemented the actual observed values in the test set, which is why I think it's some unquantified economic factor that took place, some world event or a political administration change, that substantially changed the economic behavior. In conclusion, the linear regression model appeared to perform the best with the forecasted predictors, regardless of the forecasting technique, whether it was ARIMA, VAR, or a hybrid approach. Both the XGBoost and the random forest models underperformed considerably compared to the linear regression when looking at RMSE, but overall, all of the RMSE values were substantially low enough to consider them all comparable to one another. In the future, I would implement a wider data set as well as principal component analysis or some sort of regularization, just to determine which of the predictors have the greatest explanatory effect on forecasting CPI into the future. However, this does introduce the problem of model complexity as well as overfitting. Too much data looked at too closely can cause a model to interpret noise as signal. So some sort of trade-off or balance needs to be taken into consideration.